Hi everyone, I'm Franklin Sulacho and I'm here to discuss some topics from modules 9 and 10. These are the lessons that we'll be covering up. Firstly, we'll discuss transport layer, the functionalities, connection and connection-less mode of transmission. Then we have the TCP and UDP protocols. We'll briefly explain the principles involved and also the advantages and disadvantages of each protocol and what application is being used. We'll also be discussing the application layer, then the common internet applications such as DNS, FTP, and email. The transport layer is the fourth layer of the OSI reference model. It provides transparent transfer of data between end systems using the services of the network. The transport layer controls the reliability of communications through flow control, segmentation, and error control. Two great examples of TCP two great examples of transport protocols are TCP and UDP. The TCP or the Transmission Control Protocol enables two hosts to establish a connection and exchange streams of data. And TCP guarantees three things: that your data gets there, and that it gets there in order, and that it gets there without any duplication. TCP does flow control and congestion control. TCP is used in HTTP, HTTPS, FTP, and SMTP, and many more. The UDP or the User Datagram Protocol is a connectionless protocol that, like TCP, runs on top of the IP networks. It provides a very few error recovery services, offering instead a direct way to send and receive datagrams over an IP network. It broadcast and multicast transmissions are available with UDP, and UDP is used in DNS, DHCP, TFTP, SNMP, RIP, VoIP, multimedia, online games, and many more. TCP and UDP each have their place. In fact, some applications use a combination of the two. For example, a lot of online multiplayer games use TCP for data transfer and UDP for things like client heartbeat or to send opponent position updates. TCP is generally a good choice, though even with its associated overhead, most of the overhead is in the connection. Therefore, if your application stays connected for any length of time, then the cost is mitigated. In addition, if you're sending any quantity of data, then it's cheaper to use TCP's built-in reliability, ordering, and flow control instead of building your own. And UDP is a good choice for multimedia like VoIP to provide small jitter. Next is the application layer. It's a layer in the open systems interconnection model, and in the TCP/IP protocol suite. It consists of protocols that focus on the process-to-process communication across an IP network, and it provides a firm communication interface and end user services. The application layer is the seventh layer of the OSI and the only one that directly interacts with the end user. The application layer provides many services including DNS, Telnet, World Wide Web, FTP, and email. The DNS used to resolve human readable host names. like yahoo.com into a machine readable IP addresses. This happens every time you use a domain name, whether you're viewing a website, sending email, or listening to internet radio stations. Here how it works. First is the client requests for information. The process begins when you ask your computer to resolve a host name, such as yahoo.com. The first place your computer looks is its local DNS cache, which stores information that the computer has recently retrieved. So if your computer doesn't already know the answer, it needs to perform a DNS query to find out. Step 2 is ask the recursive DNS server. If the information is not stored locally, your computer queries your ISP's recursive DNS server. Then for step 3, if the recursive servers don't have the answer, they query the root name servers. A name server is a computer that answers questions about domain names such as IP addresses. Then ask the TLD name servers. The root name servers will look at the first part of your request, looking from the right to left, and direct out your query to the top level domain name servers for .com. Each TLD, such as .com, .org, and .us, have their own sets of name servers, which act like a receptionist for each top level domain servers. Next is the ask about the authoritative DNS servers. The TLD name servers review the next part of your request and direct our query to the name servers responsible for this specific domain. And these authoritative name servers are responsible for knowing all the information about the specific domain, which are stored in the DNS records. Then next would be the retrieve the record. The recursive server retrieves the A record for, let's say, yahoo.com from the authoritative name servers and stores the record in its local cache. If anyone else requests the host record for yahoo.com, the recursive servers will already have the answer and will not go through the lookup process again. All the records have a time to leave value, which is like an expiration date. Lastly, receive the answer. Armed with the answer, recursive server returns the A record back to your computer, and your computer stores the record in its cache. It reads the IP address from the record, then passes this information to your browser. Then the browser opens a connection to the web server and receives the website. Next application is the Telnet. Telnet is an application layer protocol used on the internet or local area networks to provide a bidirectional, interactive, text-oriented communication facility using a virtual terminal connection. User data is interspersed in band with Telnet control information in an 8-bit byte-oriented data connection over the transmission control protocol. Next is the WWW, or the World Wide Web. It is being invented by Tim Berners-Lee. It is important to know that this is not a synonym for the internet. The World Wide Web, or just the web as ordinary people call it, is a subset of the internet. The web consists of pages that can be accessed through a web browser, and the internet is the actual network of networks where all the information resides. Next is the File Transfer Protocol, or FTP. It's an open protocol standard that is widely used to transport and receive large files. It can also be used to send configuration files and software updates for network switches and routers. And FTP uses port 2021 for communications and also uses encryption to protect the information being received and sent. And lastly, the electronic mail. So the main components of an electronic mail system that facilitate sending and receiving of emails on the internet are the email client, an email server, PAP, and IMAP servers. So email clients provides the ability to compose, read, and delete messages. Whenever you send a message from your email client, it goes to an email server. And that email server manages the messages received by it. It forwards the message to a POP or an IMAP service or an IMAP server. So if the message is to be sent to a recipient on the same subnet, else it follows the standard procedure to send the message over the internet to the destined person. Uh, that's it for now. Thank you for listening. Bye.